Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review what we learned in week 6. So after the test, we learned all about polynomials. It turns out fx here is a polynomial. A polynomial is just a set of terms. It might only be one term, but a set of terms such that each term is either a constant or an positive integer power of x. So this is x to the power of 1, 2, 3. The only powers of x here are positive integers. That's what a polynomial is. And we're now using this notation f of x. So if I change x here to like 2 or something, you just replace all the x's with 2. Okay, so we need to know about the degree of a polynomial. The degree is just the highest power of x. So the degree of the polynomial f here is just 3. The leading term is the term that contains the highest power of x, so it's 3x cubed. So the leading coefficient is just the coefficient of the highest power of x, which is 3. So if the leading coefficient is 1, we say that the polynomial is monic. If the leading coefficient is not 1, as in this case, we say the polynomial is non-monic. So here, f is an example of a non-monic polynomial. And constant term, you would have learned what that means in year 7. That's just the term with no x's, no pronumerals, so it's -8. If no constant term is written, like if I got rid of this 8 there, if no constant term is written, then you assume the constant term is 0. So adding and subtracting two polynomials is really easy because you're just adding or subtracting like terms. Multiplying polynomials is easy. It takes a bit of time, but it's easy because you're just expanding brackets. But dividing one polynomial by another is very tricky. So we looked at dividing a polynomial like this by a linear polynomial here. So in order to do that, we need 3 things: the factor theorem, the remainder theorem, and then polynomial long division. So the remainder theorem tells us that the remainder, when a polynomial like this is divided by a linear factor, is just f of a. So a is the number being subtracted in the linear polynomial. So here a would be 1. The remainder when this polynomial is divided by x minus 1 would be f of 1. I would just change all these x's to 1. And the factor theorem tells us kind of what we already know. We know that something is a factor if it goes into it evenly. So x minus a, this linear polynomial, is a factor of this polynomial if the remainder is 0. If I divide this by this and get a 0 remainder, then this is a factor. So f of 1 here, I just replace all the x's with 1. So replacing x with 1, I get f of 1 is equal to 0. So that means when I divide this polynomial by this, the remainder is 0. It also means that x minus 1 is a factor of this polynomial here. So remember, if I want to know about x minus 1, I don't substitute -1, I substitute the negative of that. I substitute positive 1. So let's look at how we can use this to solve polynomial equations. So sometimes we'll need to solve an equation like this. This is just my polynomial fx from the previous slide. So the idea is I want to factorize this polynomial and then use the null factor law. So factorizing means dividing. So I found on the previous slide x minus 1 is a factor of this. So I'm going to use polynomial long division to factor this. So I'm essentially saying, what polynomial do I need to multiply by x minus 1 to get this? Well, I basically know that since this is degree 1 polynomial, I'm going to have to multiply by a degree 2 polynomial to get a degree 3 polynomial. So we're going to now use polynomial long division, and it essentially just tells us what number has to go here, here, and here so that this times this equals that. This is how you do polynomial long division. You start by doing leading term divide leading term. 3x cubed divided by x gives me 3x squared. So I found a 3 needs to go up here. So whenever you get a term up here, we need to calculate the remainder. So we do this by multiplying the term up here by x minus 1. So I go 3x squared times x, 3x squared times minus 1. So to calculate the remainder, I'm going to subtract. So 3x cubed minus 3x cubed is 0. Minus 13 minus 3 gives me minus 10x squared. So whenever you've calculated the remainder, you divide by the leading term. Minus 10x squared divided by x just gives me minus 10x. So I've just found that this second coefficient here has to be minus 10. So whenever you get a term up here, we need to calculate the remainder. So we're going to bring down the 18x. And whenever we get a term up here, we need to multiply by x minus 1. So minus 10x times x is minus 10x squared. And then I go minus 10x times minus 1 gives me positive 10x. So what I do now is subtract to find the remainder. So minus 10x squared, subtract negative 10x squared, that's 0. They cancel out. But 18x minus 10x, that gives me positive 8x. So whenever you've got a remainder, you divide it by the leading term. 8x divided by x is just positive 8. So I've now figured out the last coefficient here, the constant term needs to be 8. So I'm going to check the remainder again. So I'm going to bring down this minus 8. So to calculate the remainder, I go 8 times x is 8x. 8 times negative 1 is negative 8. If I subtract again here, I get 0. And that's good. That's a way that I can check my answer. Because I found on the previous slide, when I divide this by this, I get a remainder of 0. I found that out from the remainder theorem. So what I've actually just found is this. That my polynomial fx is x minus 1 times this quadratic. That's what it means that x minus 1 is a factor. I can multiply it by another polynomial to get this here. So if I want to solve this equation, now I can just factorize this. I can just factorize this using the AC method. So remember, the AC method is I go a times c, so that's 24. I find two numbers that multiply to 24 and add to minus 10. So, of course, minus 6 and minus 4. And then, remember, I factorize the first two terms, the second two terms, and I should end up with this. So this here is equal to 3x squared minus 10x minus 8. So now that I've factorized it using the null factor law, I can find the solutions. So if the polynomial equals 0, using the null factor law, either the first bracket equals 0, which would mean x equals 1, the second bracket equals 0, which gives x equals 4 over 3, or the third bracket equals 0, which means x equals 2. They are all of the solutions to the equation. So a cubic can have 1, 2, or 3 different solutions. In this case, it has 3 different solutions. So if you don't like this process of polynomial long division, we can also use synthetic division. It essentially does the same thing, but it's a bit easier because we don't need to write all the x's. So let's perform the same division, this polynomial divided by this one using synthetic division. So we take the root of this, the value of x that makes this equal 0. We take positive 1, and we're going to use that in our synthetic division. So we're not going to write out all the x's. We're just going to write the coefficients of this polynomial. So it's 3 minus 13, 18, and minus 8. So we just have to know that this is a coefficient of x cubed, x squared, x, and constant. So this is what we do. We bring down the first coefficient 3, and we're going to multiply our root by each of the numbers that comes down here. So I go 1 times 3 is 3, and then I put that up here. So to calculate the remainder in synthetic division, we actually add things together. So that's why we had a plus 1 here, so we could add instead of subtract. So minus 13 plus 3, well, that gives me minus 10. So now I go 1 times minus 10, I'll put that over here. Of course, that equals minus 10. And now to calculate the remainder, I add 18 plus negative 10 gives me positive 8. So now I go 1 times 8, that gives me 8. So again, I add to get the remainder. Minus 8 plus 8 just gives me 0. So when we're doing synthetic division, we need to remember that this last number we get is the remainder of the whole division. So this one is now the constant term of the resulting polynomial, coefficient of x, and the coefficient of x squared. So that means our polynomial would be 3x squared minus 10x plus 8. And that is exactly the same polynomial we got from polynomial long division. So I don't mind whether you want to use long division or synthetic division as long as you get the answer right. Both of these are used to achieve the same goal. So the idea is we have a polynomial here, perhaps even a polynomial equation, and we want to divide or factorize the polynomial. We need a factor to start with, and we can tell whether or not a linear polynomial is a factor by using the factor theorem. Once we have that factor, both polynomial long division and synthetic division allow us to find what do we have to multiply by the linear polynomial to get our original polynomial. And once we've done that, we can factorize the polynomial and then factorize again as we factorized here so that we have the polynomial as the product of linear factors, and we can just use the null factor law. All right, sorry for the long video. Thanks for tuning in. This has been the luckiest maths teacher in the world. Have a great day.